Hello, welcome. Today we'll be looking at Planck's quantum of action from the photoelectric effect into brackets line separation by interference filters. Okay, so the task for this experiment is supposed to be we are finding the Planck's constant, right? The Planck's quantum of action, the value as compared to the theoretical value that we have using this experiment. So first of all, we do our settings, right? We do our settings. This is the connection that we have. Now we put this electrometer on 10 raised to the power 13 ohms. We put this on 0. We put the amplification on 10 raised to the power 0. And then we put the time constant on 0, right? So this is the settings for this experiment. Now when we check here, we realize that we have the interference filters here, right? These are the filters that we'll be using. Each filter has a wavelength. Okay, and then these wavelengths in the electromagnetic spectrum, they have their various colors, right? So the wavelengths are ranges and they have colors. This is our multimeter. We'll be using this multimeter. This is our multimeter. And then this is our power supply. This is our power supply. This is our power supply. This is the spectral lamp. Okay, we call this the spectral lamp, right? And then this is our photocell. This is our photocell. And then some connecting cables, right? So the first thing we do is we have a table like this, right? We have We have the colors here, the wavelength. We can have the voltage. The voltage is in two folds, closed and then open. Closed and then open. The voltage is in two folds. And then we can find the average of the two voltage as to the closed and open, and then we find the average here where the unit is volts, right? Okay, so first of all, we have to close this, right? For white light, we can see that the photocell has an opening. The photocell has an opening. Open and then close. The photocell has an opening. Open and then close. So we bring it closer to the spectral lamp. And then we'll close and record the corresponding. We set the voltmeter to 2 volts. Then we record the corresponding voltage when we close, and then we open the opening of the spectral of the photocell. So when we close it, the voltage changes. When we open it, the voltage changes. So we open, and then we close. Then we record the corresponding voltage. So that's for white light. The next thing we do is we bring the interference filters, right? We can start from the least wavelength. So we can start with this wavelength, 366. So we record the wavelength here and the wavelength here. So white light first, wavelength here, the colors here. So we place this at the opening of the spectral lamp, right? This way. Place it at the opening of the spectral lamp. Then we bring it closer, wait for some few minutes, right? Then we open and close. Then we record the corresponding voltage. Or open and close, we record the corresponding voltage. Then we change the filter. So you can see that this filter is giving us a green color, right? Then we change it, we open and close and record the corresponding. This filter is also giving us this color. This filter is giving us a violet color. So that's what we'll basically do for all the filters. So we put the filters on the spectral lamp, then we bring it closer to the photocell, wait for some few minutes, then we open, we record, then we close, we record, right? For all the filters that we have here. Okay. So at the end, this is the equation that we'll be using for this. This is the Planck's constant that we'll be finding. So comparing it to an equation for a linear equation, this is supposed to be the u. This is u. This u is supposed to be our y component. This f is supposed to be our x component, and then the whole of this will give us the intercept. Now, it means that our slope will be equal to the h over E, where E is supposed to be the electron volt. E is electron volt. And then we equate the value of the slope we have in the graph from the slope, the value of the slope, to h over E. Then we can find our E.